fast, silent, deadly. America's newest nuclear submarine is a game-changer, packed with advanced weapons, cutting-edge tech, and stealth capabilities. It's built for speed, precision, and survival in the most hostile waters on Earth. So, what makes it so different from older subs? And why does it matter now more than ever, as global powers fight for control of the seas? Let's dive into the tech behind this next-gen war machine, and why it's shaking up the global balance of power. For over 40 years, U.S. stealth subs have silently guarded the oceans, but they're aging fast. The Navy is replacing them with a new class, the Columbia class, a fleet of 12 ultramodern nuclear submarines. Price tag? At least $130 billion, more than many nations spend in a year. America's nuclear defense relies on the nuclear triad, land-based missiles, bomber planes, and submarines. Of the three, subs are the most important. They're nearly impossible to detect and can stay hidden for months, always ready to strike. But today's subs, the Ohio class, are getting old. First deployed in the 80s, they're expensive to maintain and outdated. The Columbia class is here to replace them, smarter, stronger, and built for the future. Construction started in 2020. The first sub, USS District of Columbia, SSBN 826, is set to enter service in 2031. These giants are 560 feet long and 43 feet wide, slightly larger than the Ohio class, to fit more modern tech, smarter systems, and better crew quarters. Each will carry 16 Trident II D5 missiles, with newer subs upgrading to the D5 LE2. Nukes that can travel thousands of miles and hit with terrifying accuracy. Why 12 subs? The Navy crunched the numbers. How many nukes need to be ready at sea? How often subs need maintenance? And how many can stay hidden and launch ready? That math led to the perfect number, 12. To cut costs, the Navy considered three options. Upgrade current Ohio subs, add missile tubes to Virginia-class attack subs, or build something entirely new. Surprisingly, starting from scratch turned out cheaper and better. Older designs needed costly midlife refueling. Columbia-class doesn't. In short, the Columbia-class sub is the future of American sea power. Silent, strategic, and always ready. The Columbia-class submarines offer a major advantage with their nuclear reactors, which last the entire lifespan of the submarine, eliminating the need for refueling and allowing for uninterrupted service. To ensure success, the Navy completed a detailed 300-page design plan in April 2014, with 159 technical requirements covering weapons, escape routes, and internal systems. The key decision was a length of 560 feet, providing ample space for complex systems needed for long-term operations. On July 28, 2016, it was announced that the first submarine in the class would be named Columbia, in honor of the District of Columbia. This was officially confirmed by Secretary of the Navy Ray Mabus on December 14, 2016. Then, on October 28, 2020, Navy Secretary Kenneth J. Braithwaite revealed the second submarine's name, USS Wisconsin, SSBN 827. Two key challenges facing the project include maintaining the supply chain and ensuring enough skilled workers are available for the highly specialized tasks required. Even a small delay in one area can impact the whole schedule. The Columbia class, also known as SSBNX, is still in development, but it will be designed for 42 years of service, completing around 124 nuclear deterrent patrols. A major upgrade over the older Ohio class is the nuclear core, which eliminates the need for costly midlife refueling. Although the Columbia class carries 16 missile tubes, fewer than the Ohio class's 24. Each is 87 inches in diameter, large enough to hold a Trident II D5 missile. Despite fewer tubes, it maintains the same strike capability with more efficient systems. The new submarines will feature advanced technology and stealth, remaining undetectable and mission-ready for their entire lifespan. The design also includes X-shaped control fins at the rear, improving maneuverability and reducing noise. Additionally, the dive planes are now positioned on the sail, vertical tower, for better control and stability, particularly when moving slowly or near the surface. A key upgrade is the switch to an electric drive system, which replaces the older mechanical gear system. This new setup uses steam to generate electricity, reducing noise and enhancing stealth, making it harder for enemies to detect the submarine. The 40 mini power plant generates electricity to power a motor that silently turns the propeller, much like how electric cars use battery power to drive the wheels with minimal noise. For a submarine, staying quiet underwater is crucial for stealth, and this new system helps achieve that. To reduce costs and speed up production, the Navy is incorporating technology from previous submarine programs, especially the Virginia-class fast attack subs. The Columbia-class will feature a pump jet propulsor, which is quieter and more efficient than traditional propellers. Its hull will be coated with an anechoic layer, a rubber-like material that absorbs sound, making the sub harder to detect by enemy sonar. The submarine will also include a large aperture bow sonar system to detect other ships and subs from far away. Additionally, the Columbia-class may use an advanced combat system, the Submarine Warfare Federated Tactical System, which integrates sonar, optical imaging, and weapons control into one network. This allows the crew to make quicker, smarter decisions, reducing long-term costs and increasing the submarine's stealth. The Columbia-class will feature a fully electric drive system. Unlike older submarines that use nuclear power to drive mechanical gears and shafts, similar to a bike chain, the Columbia-class replaces this with a quiet electric motor, just like modern electric cars. This reduces noise and makes the submarine harder to detect. The submarine will still be powered by a nuclear reactor, which heats water into steam, driving turbines that generate electricity. This electricity powers the propulsion motors and all other onboard systems, like computers and life support. Turboelectric drive is not new. It was used successfully in U.S. battleships and aircraft carriers in the early 20th century, and in small nuclear subs like the USS Tullabee in the 1950s. Larger subs, like the USS Leonard P. Lipscomb, also used it, though they faced maintenance and power issues. Engineers have made significant advancements, and the Columbia-class will incorporate modern electric drive technology to avoid past issues. As of 2013, only the French Navy's Triomphant-class submarines used turboelectric systems. In 2024, Northrop Grumman was selected to design and manufacture the turbine generator units for the Columbia-class subs, while Leonardo DRS was chosen in 2014 to provide the main propulsion motor and system. This motor, which converts electricity into motion, was delivered in August 2022 for the first submarine. Electric motors are becoming essential for both military and civilian ships due to their efficiency, quieter operation, and ease of maintenance. The U.S. Navy is exploring advanced electric motors for future submarines, including the permanent magnet motor, developed by General Dynamics at Newport News Shipbuilding. These motors are smaller. Superconducting motors are quieter and more efficient than traditional ones, making them ideal for stealthy underwater missions. American Superconductors and General Atomics are developing high-temperature superconducting synchronous motors, which reduce energy loss and enable powerful, compact motors for submarines. Germany and Italy already use similar motors in their Type 212 subs. In 2013, the U.S. tested permanent magnet motors on the large-scale Vehicle 2 prototype for future submarines like the Virginia-class. The UK's Dreadnought-class subs may feature a shaftless electric drive system, potentially transforming submarine propulsion. Comparing the Columbia-class to China's and Russia's nuclear subs, China's Type 094 Jing-class carries 12 JL-2 nuclear missiles, with a shorter range than the U.S. Trident missiles, forcing Chinese subs to operate closer to targets, making them easier to detect. China is developing the quieter Type 096 with JL-3 missiles. Russia's Boryai-class, Project 955, carries 16 Bulava missiles, is quieter, and more advanced than older Russian subs. Technology plays a huge role in modern submarine design. The Boryai-class is slightly smaller than the Columbia-class, but still very capable. U.S. subs benefit from more advanced electronics and navigation due to higher investments in undersea tech. China's Type 094 is still catching up, while Russia's Boryai-class is a strong competitor. The Columbia-class, however, leads with cutting-edge nuclear power and missile systems. The UK operates 4 Vanguard-class subs, which carry Trident II D5 missiles like the US Ohio and Columbia class. With a continuous deterrence policy, one Vanguard is always on patrol. These aging subs will soon be replaced by the Dreadnought class, which offers better stealth, longer service life, and enhanced capabilities. The growing US-UK collaboration on missile systems highlights the increasing role of submarines in nuclear strategy.